Okay. It's fine. Okay. Good afternoon, everybody. I'm Vukosi Marivate. I am chair of data science here at the university and a professor in the computer science department. And I run the data science for social impact research group and also the interim director of the new African Institute for Data Science and AI also at this university. Very proud at the moment to be hosting Dr. Gichoya, Judy. Judy comes from Emory University, but is an African native, originally from Kenya. And one of the reasons we're doing this, I know there's a lot of people online as well, and then we are in the health faculty and in the library here, was because we tend to get a lot of requests about how do we engage data science, AI, and health. And I really thought there would be nobody as good as Judy to be able to take on this topic. So we're really happy to have her here. So she will give her talk, and then there will be some time for questions. The session is recorded just for everybody. Unfortunately, we will not allow AI agents or everything, so they will be kicked out in this in this space. We will do just post-processing that needs to be done on there. And then Judy will introduce herself, and then, we'll
Awesome, thanks. So I'm not as loud as Vukosi. So the people who are back, if you want to come closer, that would be awesome. But if you can hear me, you can sit where you are. And I chose this topic just based off a little bit of naughtiness, like everyone is, writing how much AI for healthcare, and chatbots. And I thought, just to pick it as a just being mischievous. So, but also to make me think. So, like Vukosi said, I am, my home is in Kenya. This is where I went to medical school. This is, if you've seen the Kenyan runners, right? The South African runners are good, but the Kenyan runners are very, very good. So they come from a place called Eldoret, which is where I went to medical school. And during this time, something amazing was happening, and which was computerizing some of the medical records. And the most recent pandemic most of us will remember is COVID, but during when I was a medical student, we were really struggling. Pretty much everywhere in Africa was struggling, and the world was struggling with HIV care. And so a lot of early viewer provider, then people were trying to say, when were patients dying? When are patients, like, could we give them ARVs? A lot of work was done, and there's a lot of data just that has transformed the care for HIV patients, right? So we see now children who are born as HIV positive who are now adults, and now we have to think about chronic diseases. And so it's just it was very transformative to see this. But the lesson that I learned is are really two things. This was the computer medical record system then. And it may be hard to believe today because we have a lot of maximum, numbers of, we had like a maximum number of Excel rows that you could have on a spreadsheet. And so you couldn't like have unlimited patients as we have. But I learned about two things really, that data science, not AI or anything, data science has a transformative role in medicine and organizing how medicine is provided. And this has, this inspired my career. And secondly, that if you lead with care, if you're grounded on something, right, which is maybe transforming patient care, then you can really make good decisions. And because not all technology works, and this is going to be important as we go through this talk, just to make sure, because there's a lot of hype right now with technology, but a lot of people have been doing the work, and then you're like, okay, should I jump onto this bandwagon, or how do you navigate this? And I hope we can have some dialogue about it. So I completed medical school. I moved to the US. I still teach. This is me teaching Dr. Rukundo in Rwanda, the first interventional radiologist in Rwanda. So I'm an interventional radiologist, which means that I do procedures guided by X-rays, right? Minimally invasive procedures. This is a tumor for hepatocellular carcinoma that we're treating using a procedure called TACE. And, so I've been able to come back, not just for AI really, like this visit, but just to teach the first generation of subspecialists who can provide minimally invasive care for primarily the East African region, and that's been very transformative. But this is an AI talk, right? So, and it started off by saying chatbot. So this is really the first chatbot. I'll stop for just a few seconds for you to read, so that I don't have to read because I may exaggerate it. That's not what people may sense it. But this came up in 1966. So this is done by Joseph Weizenbaum, who created the first chatbot. And this is a rule-based chatbot, and it's, it's pretty much using how we use language, right? Prof. Bukosi is very fascinated about language, and even the low-resource languages that are spoken in many parts of Africa. And, so you can see that the chatbot, like men are all alike. And then the chatbot, these are just rules. It just is fed with a more likely what you would have said, like in what way, right? It understands when it's a question, like maybe probes you a little more. But he was very, very surprised that the people who saw this chatbot believed it, actually, and were very impressed. We've seen a lot of work that are saying people prefer talking to chatbots more than, human beings. And so we're seeing them now in the era of generative AI, which is like ChatGPT, the system that powers ChatGPT, where we're seeing that people are saying, they can be creative, they can be emotionally intelligent. I didn't put, here's an example. You can have an AI girlfriend. You can make them do, look how you want them to look, tell you things. The AI girlfriend does not need to disagree with you, or the AI boyfriend too. They cannot disagree with you. They can talk to you anytime. They're never tired. They're never grumpy, right? So we're seeing a lot of society changes based on these chatbots, but it's not all rosy, actually, right? So we've seen a lot of suicide attempts, because the chatbot maybe forgot something about you, right? And this is just because of how they're programmed, right? If their memory is wiped out or an upgrade comes, then it doesn't remember that last week you talked about your trips to South Africa, then people get very devastated, right? So a lot of, especially if we think around mental health, people are, very sensitive to sort of like the communications that they can have. And so this article actually in the Wall Street Journal was really looking at that the timing of adverts was even trying to look at when teenagers tend to be depressed or near exam times, or people are stressed, right? Then they'll show you more adverts that maybe are around body image. And so we are always being surveilled, right? And the marketing is, people try to create a psychological profile of our marketing. And so, actually, unfortunately, this morning, I saw that the United Nations, UNHRC for refugees made an AI refugee, right? And who was speaking about the experience. And a lot of society questions were coming up and saying, do we really need an AI-generated refugee when we have so many refugees that they can tell their story, right? And so, this is sort of like, I put this because chatbots are so, they give us a mental model for us to discuss where we can, move ahead with AI for healthcare. Because, I think most of us in the room will at least understand, even if you're not using a chatbot for healthcare, you're using a chatbot you've used a chatbot either to get help from Delta, or help from, South African Airlines, or help from the bank, or you have a form of chatbot. And people really think and are betting that this is going to be so transformative, and it's going to be so transformative even more for Africa, that does not have enough doctors, and this is how we're going to leapfrog, just like how we've been able to leapfrog mobile phones, right? We don't see a lot of telephone poles trying to keep us connected. So with that sort of background, that's why I said, why don't we discuss how is healthcare used in Africa, how is AI used for healthcare, and how could it be used for our context in South Africa, in Kenya, or pretty much anywhere else? And so since I'm a radiologist, I'm going to be biased. I'm going to be speaking about radiology. And I want to start off with this guy here. How many people know this person? Good that you don't. Oh, one person knows him. Who is he? One of the godfathers of AI, right? So this guy in 2016, right? So he won, last year he won the Nobel Prize. At least we do know the Nobel Prize, right? And this was done for physics and for his work for foundational discoveries and inventions that enable machine learning with artificial neural networks. And so Geoffrey Hinton, in 2016, I was still a radiology resident, said that if you, I think if you work as a radiologist, you're like Willy Coyote. This is not something that I understood. I had to look up what it is, but it's just a cartoon and it's hanging over the cliff. And you're already over the edge of the cliff, but you haven't looked down. People should stop training radiologists now because it's completely obvious in 5 years, deep learning is going to do better than radiologists. I did have a chance to ask him about this, and he always says he was misquoted, but these are his words. Actually, it's on YouTube. I mean, we didn't even have generative AI where you could make him say things, but this actually caused a big problem for our specialty, and it became because people were saying, why would I want to become a radiologist when I can be replaced, right? And so this, spurred a lot of my interest around understanding how AI could be used for radiology. Now, one way to understand what's available is to look at the regulatory landscape, right? Now, we know most of the places in Africa, there's, you can go through like the products and poisons board and they can approve a product, but it's not really, I think, for my example here, I'm going to use the FDA, which is the regulatory landscape for the US, and also the CE for Europe. And if you look at this picture, this is always a great website if you want to figure out where to get more information about some of the products. But you can see most of the work that's being done is around chest, cardiac, and neuro, right? Head and neck imaging. And this radiology there are 1,000 products that are approved by the FDA, around 1,000. More than 700 are in radiology, right? So this is, using radiology to discuss healthcare AI is not a bad thing because we're pretty much some of the leading people in this space. And if you look at sort of some of, year after year, things have gone up. We've seen, for example, things that tell you the brain anatomy, especially for Alzheimer's, a disease, anything that's measuring cardiac, cardiac measurements, things like pneumothorax, breast density, intracranial hemorrhage. At Emory University, where I work, we deploy 5 algorithms. One is an intracranial hemorrhage detector, right? So it takes time before the radiologist here, even in the US, interprets your study, but you don't want to be waiting for days to be told your patient has a bleed, also a pulmonary embolism. And we also use a lot of AI systems that help us with documentation, right? So a lot of people were trying to send agents to attend their meeting today, right? So similar thing where you can discuss sort of with, you're sitting with a patient, it documents your report so that you have a better documentation instead of going to type your note, right? So also helping with radiology assisting. So even if there are 1,000 algorithms, we don't really deploy most of them. And that's, I want to give a context that you can build, I know this because our group does build algorithms. It takes around maybe 3 hours now because we have good data sets to build a model, but it doesn't translate to the healthcare. And it shows you that it's really still difficult to make an impact on the healthcare system. Now, we've seen also autonomous AI, and this was approved in Europe. And what it was doing was just saying, here's a normal or abnormal chest X-ray. I think this one could have lung cancer. And it was not going to give a human in the loop, right? So we're seeing this new movement that AI could walk alone, right? And a big push for that. Unfortunately or fortunately, this company went under bankruptcy. That also shows you again that it's still very difficult, even if you have just an AI model, to have an impact on, just on the medical part. So based on sort of showing you the stories, the detour about bots and what people are thinking, why everyone is always saying, we see a lot of use for bots, this could be transformative for healthcare, and showing you that the marketplace has a lot of products, but when you come on the ground, we don't really see as much success. Then I thought that we'll use radiology to understand some of the basic things about artificial intelligence, and then discuss some of the use cases that we have seen and where AI fails, and then maybe end with trying to say, why is it different? And have you think what could be the application that actually makes a difference in our practice today. So here are always my answers, right? You always, because there'll be many slides, you want to make sure people don't forget what you're trying to tell them. And I always say when in response to Geoffrey Hinton, now this, maybe 2 months ago, Bill Gates also started saying we don't need doctors anymore. And what I think 4 things that affect why AI has not been successful for radiology is that training of AI, and I'll show you this, relies on pattern recognition, but the pattern is not always synonymous to the disease that is being taught. And I'll show you some examples about this. And so models seem to fail on many shortcuts, and this has a big implication for some of the data sets that are curated from Africa. And if you bring a human in the loop, then you bring unpredictability. And so a lot of AI use, and this is a big issue even for just medical students who are going to learn with ChatGPT, then it brings automation bias. You can reduce your critical thinking. And so we have to think who or what makes a good radiologist or what makes a good doctor, and then what affects their performance. Because if you don't design the AI in a way that their performance is optimized, people are either going to ignore your solution or they're going to not really they're not going to get the benefits of using AI. And then previously, now, when we say AI today, I think for the purposes of practical use, we can divide it in 2 things. One of them is the deep learning, and I'll show you this. But we can also think about generative AI, the technology that's powering ChatGPT, or all this newer generative, anything that produces text, videos, or audio. And that is seen to be the general AI, and everyone is betting that we are going to have a lot of agents. Even if you're like me, you will have someone who can make your slides, do all these things for you. But this is sort of like the hot thing now, and people are trying to figure out what that looks like. But I think that everyone is betting that we need to move away from narrow AI to general AI. But I'm saying that switch is not as easy. And then it's easy to forget that technology is not the solution for problems that have existed for a long time. And so there are things in our world. For example, we don't have enough doctors, we have workflow issues, and those cannot be solved by technology, but it's easy to think that bringing AI is going to solve them. So we're going to be discussing around these 4 things that I'm going to be trying to make a case for them. So I mentioned that, for people who may not have comfortable with AI is, if you think about our senses, we can see, we can hear, we can, reason, is sort of trying to teach machines to do the same thing, to become intelligent, but to mirror our senses. And so there are various terminologies. If we get into the debate of what's strictly machine learning or deep learning, we're never going to leave. And so I'm just going to say loosely we'll be using deep learning because those are the more modern approaches that we've used. And so different from previous, in deep learning, you have data and you have the answers, and then the algorithm, the box, decides what exactly are the rules that need to be followed. So for example, if you have oranges and bananas, okay, and this is your data, you already know the answers to these 2 things. You want the algorithm to classify whether it's, to differentiate between whether these are, this fruit is going to be an orange or a banana. You give it enough examples of those 2 data sets, and you say these are the labels, and the algorithm iteratively, decides, and you can tune a few things, and it decides that, oh, I see that this is a banana, or this is an orange, and it gives you some metrics to do that. And so if you think about imaging data, this is one of a pixel image of Abraham Lincoln, a previous president of the US. Everything has to become zeros and ones, right? So, the black represents lower numbers, and white represents higher numbers, and you end up with a mathematical grid like this that's fed into a machine learning, and with a lot of computation, we'll end up saying, oh, okay, I realize this is an edge, this is something else, and as the network goes across different layers, it learns different things, right? So that's why you hear this deep neural network. And so when you feed it an image of a bird or an orange, then it tells you with some probabilities whether this is a dog, bird, or cat. That's a very simplified view, but it's important just for us because this is not the technical overview. And so we use the same model that classifies dogs and cats to tell you, is this a pneumothorax? For radiologists, for non-radiologists, this is free air around the pleura here on the right side. And here, the AI just tells you, I think there's 60% chance of pneumothorax, or you can just say yes or no, right? Or you can draw a box, so we call those detection tasks, right? Where now you're not just guessing, like, where could the model have been looking? Now you can see, okay, I see this is the general region that you're looking at. This is used quite a lot in self-driving cars, right? It classifies things and says, oh, here's a pedestrian, here's a bicycle, right? So it's the same algorithms. And then one more is that we see that you can even be very precise. For example, if you have a tumor, and you need to be very, like for radiation therapy, right? You cannot be radiating the whole test. You need to be very precise. So you can draw, and this is called segmentation. This takes quite a lot of time to do. But that's a little bit of the deep learning network, the one I was showing you, the cats and dogs with the many neural layers. But now we've moved to generative AI. Generative AI is saying, look, if you train like all of us who had to learn biochemistry, pathology, and all those things that sometimes you don't use anymore in your life, all those subjects give you a basic understanding of many things, right? And then you can now become a surgeon, you can become a pediatrician, you can become a nurse on top of just the basic understanding, right? And so the foundation models are treated the same way, but if you feed a lot of images to them, then what you can be able to do is something like this, if it plays.
Describe what image I'm scrolling through right now. The image you're showing is a CT scan of the abdomen. It displays the liver, stomach, and surrounding structures.
What organ am I pointing to now with my cursor?
You're currently pointing to the spleen with your cursor.
Okay, Gemini, what am I pointing to now? What organ?
You're now pointing to the liver.
Okay, so I'm scrolling down here now. Gemini, what am I pointing at now? What organ is this?
You're now pointing at the pancreas.
Okay, and do you see anything abnormal on this scan?
Yes, there is a small amount of fluid around the spleen and the pancreas on the scan, which could be a sign of inflammation or injury.
Okay, anything else that you notice about the pancreas?
The pancreas appears somewhat swollen, which could suggest pancreatitis.
Okay, the patient has an elevated lipase level. What do you think about that?
Given the elevated lipase levels and the appearance of the pancreas, it is highly suggestive of pancreatitis.
Okay, what complications should I be looking for?
Based on the scan, you should be looking for complications like pancreatic necrosis, pseudocysts, and infection.
So now this is all AI generated, right? So you feed it up a video, you keep asking, right? You're interacting with voice, it learns what it's supposed to see, and then comes back and says, this is what I'm saying. Now, for the radiologist, you would not spend that much time. You'd already said this is acute pancreatitis and move on. But you can imagine for medical students or people who are not comfortable, this is a powerful tool, right? To start, or even patients, right? Who we send a lot with all these images that they don't understand. They can actually now come back and say, oh, I can ask questions. If you do the work like Vukosi, you can ask questions not only in English, but you can ask them in a local language, right? So very transformative technology. And so these language models, right, this generative AI, the way it's trained is actually, this is AI generated text, right? And you give it a lot of text. You can give it anything. You can give it videos. You can give, anything, and you fill in the blanks, right? And this is important because in the past, remember my orange and banana example, you still have to say this is an orange and this is a banana. But in this text, you don't have to say that if you're just filling in the blanks, right? Because you're just blocking, one part of the word, and you want the model to predict the next word, right? So it removes the amount of labeling that is necessary for you to train this model. And so that's why they require a lot of text, a lot of compute, and then you decide what you want to do with them. And so people are betting that the future is really going to be this foundation model. And this is what powers a chatbot. And what it would do is that it would, understand text, audio, it would understand genomics, it would understand the images for the patient, the electronic medical records, and the labs and the medications. Then it would also be grounded in medical knowledge, for example, the literature, publications. And then now you can have a chatbot here that says, interacts with it, like the video that I showed you, or you can have for example, in radiology, we have a couple of this type of models. And now what they can do is generate a report for you. Instead of saying this has pneumothorax, it says, here's a report that is AI generated, not by a human being. And now you have a complete report, right? It's pretty transformative if you think about it. But of course, if it worked, all of us would be using. That's why I started by saying, even if we see a lot of excitement, it's not as used, as frequently. Now, this era of generative AI, because it requires a lot of compute, one of the things you'll hear is that it's very toxic to the environment. And also, not everyone can train these models because you need a lot of GPUs. It costs millions of dollars to train these models. And then they rely on stealing everything because you need all the possible text in the world, like all the library, all the books in this library and any other library, so that you can train your model. So people, artists can lose their intellectual property. And they also have for us, we deal with sensitive medical information. So if your sensitive information is fed into the model, and we don't disclose what is used for the model, then this can be problematic. And so you find that these large language models, they can be vision models or whatever, they can release and leak protected information. And finally, they hallucinate a lot. So here is one I did many years ago. Give me my 5 most cited papers. I've never written any of these papers, but if you look at them, they're very convincing how they're written. I'm an interventional radiologist, so the journal that I'll be publishing in is probably correct. And so you have to verify them a lot because AI never tells you it doesn't know, right? That's the problem for us in medicine. I don't know if the medical students are still evaluated this way. When I was a medical student, there was always true, false, and I don't know. And if you picked false, you'd be penalized for guessing because they thought that the lesson was to teach you not to guess and ask and say you don't know. But AI does not know that. So when you combine the generative models, so you can say, for example, it feeds this image and generates a report. Here is one of the models from Microsoft that I tried with this chest X-ray, and it's giving you a list, but you can feed this into a model, and it's giving you a box trying to show you where it thinks the abnormalities are. Here in this case, there's a borderline heart, and the model is able to catch it, but it also hallucinates that there are breast implants that are not in place, right? So this is the problem, that the reports are so believable that, but you have to really be critical to be able to catch them. So when I say, as I said that we're gonna go through these 4 things, when I said that the future was narrow, the future was more controllable, true was not at scale, but it's clear that the next AI that is probably going to be deployed in most places here, it's going to be this generative AI that is going to be generating a report, but it fails from the same reasons as any other ChatGPT or anything failed. And you have to remember that the same AI that is being used to train cats and dogs is the same one for medicine. It's not different. And so the same mistakes you see whether you're using your TikTok or anything else, are going to be the same problems you see in the medical one, right? And so, and even if we're saying that we're going to move to agents, they're promising, but when you see that the models still fail on the small things, that becomes problematic. And what we should be asking ourselves then is, how do we design and how do we monitor and evaluate these technologies as they come to us? Because they are going to come. You can be sure about that. Even if it's not you, your patient is going to upload their images. Remember, our patients are very, very savvy. They're going to upload their images and they're going to get a report. And if it's different from yours, you have to be able to be answerable. And hopefully you've not missed something. Yeah. So second thing, a lot of things, when Geoffrey Hinton said, stop training radiologists, most of us said, radiologists who use AI will replace those who don't, right? This is a very common thing. And, we've been using AI for a bit. This is a study that is reviewing AI in practice, and it looked at 65 studies. And what we find is that it's mixed. Some people, it's looking at 86 studies. Some people report an improvement when they use AI. Some people don't see a difference, and some people see that they get worse, right? So not everyone gets the same amount of effect. And so, when we look at, for us, I told you we have an intracranial hemorrhage. This is a brain bleed model that works in Emory. And when we look at it, it only saves us 10 seconds per patient, because radiologists, at least in our workflow, are very efficient. And 10 seconds does not really make a big difference, and you also have to be careful, because if you're trying to make people faster, your boss, everyone always has a boss, is also wants you to read more studies, right? So you have to figure out what's the most important value. And I'll tell you that if you're an emergency room doctor, then you want your studies to be quick so that you can let your patients go home, so that they're not spending all the time. But if you're a cancer doctor, you want the radiologist to be slow so that they can look at all the images that have been done and tell this patient, is our cancer better or not, right? So speed is not the value that you're always looking for. But the design of these models does not really value or understand. Or let's say you have a resident that you have to teach. So speed at that point is not the biggest thing, because I need for the resident to make mistakes so that I can teach them and provide a learning opportunity for them. So we've looked at these models further, and this is just showing all the possible ways you can evaluate these models. And we find that, interestingly, that the models are only able to tell you when there's a big hemorrhage. So this, red, brown, maroon thing, when the hemorrhage is more than 1 centimeter in size, it involves multiple compartments. And that image, if you've walked by the radiology and you saw the CT scanner, anyone can tell you that's a problematic scan. It turns out that the ones that are hard for the radiologist, the model also struggles with them. And so, that's also why most people don't find it useful, because this is something that takes me a second to make a decision. But the things that I'm struggling with, for example, in this example, where we look at how an AI performs, this is work from my group, we look at how an AI performs for breast cancer detection. And it has a cutoff point, because you have to decide, what you're going to call normal and abnormal. If it's this way, it's cancer, and if it's on the left, it's normal. And we find that this non-invasive cancer, which is ductal carcinoma in situ, very early cancer, the AI misses 45% of those cases. That's the earliest form of cancer that would make a difference if you made a diagnosis on a patient. And so we find that AI does not, when you come to think about it in the clinical setting, is not consistent in its predictions, and it tends to fail for the most. It works very well for easy cases, but the hard cases that are even hard for the human, it's not very good. And for you to really bring value, then you have to say, these are the cases. It's not just time that it's important for me, but these are just the cases that are very difficult for me, and I then can use another person to help me. One other concerning area here is that if you give the human the wrong output, so this is a study that said, some patients have cancer, some patients don't have cancer, and it just made, the AI made a mistake intentionally. And what they found is that your expert, when you give everyone the right answer, everyone's performance improves, right? So AI has potential to improve everyone's performance. But when you give the human the wrong answer from AI, the performance of everyone drops, even your expert. So that means you can mislead with your AI algorithm, you can mislead your radiologist or your doctor. And so it's not just bringing AI to the system, because you can actually have, you can have problems because of where AI fails and how you present the information to the, to the doctor. So when, we stopped, I initially said, justifying this move from narrow AI to general AI, but this, when you bring humans in the loop, we don't understand today how to optimally pair AI with humans. And this is probably where we can learn from the chatbots, because automation bias, human factors, the explanations, the timing, these are the things that really matter. And that's where it's not enough to just build a model. You have to really come and check what your humans are doing in their workflow so that you're helpful to them. And this is an area of a lot of active research for people who are looking for topics to study. And so I want to show some examples of how AI fails from these shortcuts. You hope that when you're maybe showing the example between oranges and bananas, that AI is going to learn the color could be different, the texture of the fruit could be different. Those are the things that it learns and then uses them to predict. But it turns out that, for example, here for pneumonia prediction, AI relies on these radiographic markers, these hot red areas. Those areas are very synonymous, and they can tell you whether this patient is in the ICU or not in the ICU. And we all know that pneumonia would be found in the lungs, not outside the lungs. So if the eye is looking outside the lungs, then it's most likely problematic. And, it's really, it's not relying, and that's why AI was never helpful for COVID detection, because it doesn't really, it looks at what's the easier thing. And here it just learns, if you're in the ICU and people are getting a chest X-ray, you probably have pneumonia. I'm just going to guess that you have pneumonia, and it's usually correct, And remember, I told you AI doesn't know when it doesn't, when it doesn't say, no, I don't know. And here's another example where you say, predict a hip fracture. This is a busy slide, and I'm just showing you can have so many factors that are captured during just a picture for an image. There could be hospital factors, there could be the time of the patient, the type of scanner, and for the you can extract the features of the images and you can visualize them. And at least even if you don't know anything about computer science, you'll agree that there are three big clusters here. And if you start to overlay things on them, you can see that the fracture, when a fracture is present, it's mainly present in this green scanner, right? So it's the one that is, and it could be just because your hospitals acquire different equipment. And so when the study team here says, I'm going to predict who did this study, what was the time of this study, the model does a very good job, much better than telling you that the patient has a fracture, because it's able to figure out some of the characteristics of our images that make it easy for it to predict. I mentioned about segmentation, and here's an example. This is an ultrasound of a baby used to measure gestational age. Here we have a ruler. And when you have a ruler, the AI has a perfect prediction. But when you have no ruler, the AI starts to struggle to locate the lesion. We know that I've mentioned around foundation models, and it's not unusual, especially if you have to present in a tumor board, for you to write things on the slide so that, when you have to present them, that it's easier. So for example, this is saying, this is the carcinoma, this is, there are all these labels on slides. It's not unusual. And so, people think that the models really learn the things that they are learning, but it turns out that when you remove the label, the model cannot make any prediction. And when you have the correct label, the model makes a perfect prediction. And when you have no label, the model guesses whether they think this is cancer or no cancer. And you'll hear something being told about prompt engineering, like that video showed, like maybe direct the AI to the right place. But it turns out that that's not enough, sufficient enough for you to understand, for the model to look at what it's looking at. And so when we look at AI for radiology today, we see that it really doesn't work. At least that's what we've seen, and that's unfortunate. We've ended up looking at 13 algorithms for our institution, and this is because the reality of how doctors and nurses and clinical officers care for patients is really difficult. It's not reproducible across places. And so I'm increasingly saying that all AI is local. And I hope that if you're going to take one thing, it's going to be that even if you feel intimidated about this AI thing, that you have to learn just a little more and participate. Because if AI comes and it's not, you have no say in it, it's not going to really help you. I think that we are in a big area of the hype, especially with the foundation models, the chat GPTs, they can help us in other tasks. And, people are now increasingly applying them. Every week there's a new model, and they're applying them to, not only for education, but to generate reports. And people are going to rely on them thinking that they are correct. But as what we know today is that they really, really struggle when it comes to evaluating them critically for their work. And finally, I said that we have to think about these non-technological factors that affect us. In my world today, even if we have a lot of radiologists in the US, we still have a big backlog of examinations. We see a lot of venture capitalists buying hospitals. It's actually starting to happen in Africa for radiologists, where you're finding some of the big venture capitalists are coming and buying the profitable places. They're the same people who fund AI projects. So there's no incentive to think that that's not going to happen. We have different people. People may say, for example, in Africa, we don't have enough, radiologists, or X-rays are never read. So maybe if they're not read anyway, why can't we just give it to AI, right? AI is better than not being read, right? So that's a common statement you'll hear. And actually, the reason I was showing you the shortcuts, for example, the L marker, is to show you that most of the studies, for example, when I'm in Tanzania, are actually abnormal, because you're not scanning many people. Now, in a private hospital, or maybe in South Africa, you maybe see more normal cases, but most of the studies, they're late disease, they're abnormal studies. People are not sending you to get a CAT scan just because they feel like they can get a CAT scan. And so if I compare to the data sets that I have in my workplace in the US, most of those studies are normal. And so if I build a model on my population in the US, then it knows what normal is. It doesn't know what advanced disease is. And if I bring it here, it's not going to work, because just the same way it's learned not just the disease characteristic, but the shortcut that are necessary for it to understand the pattern. And then, so we have to think a lot just about our workflow and our characteristics of our patients that makes it, and if you're even in a referral center, you're providing care to someone who lives 2 hours or 3 hours away, right? So it's very different about the bigger picture that you have completeness of the patient. Finally, I want to talk about this, it's not just medicine. You may say, what, I don't care. It's not going to work for me in South Africa or Kenya, but we know that AI is in our world today. One, because if you're on social media, your new friend could be a fake friend, right? Generated by the fake AI profiles, because to increase engagement. This is easy to feed you because they learn the things you like, the profiles that you're always spending time on, right? When you hover, when you like, when you do a thumbs down. So then they amalgamate those features, and then they make a profile for you, right, that you can interact with. So you could be interacting with a fake person. It's preference, right? So that's one thing. Then they can also figure out the timing, like you like to post, right? So you can see a lot of things that we have to think about how AI comes. I'm Kenyan, so we know that a lot of the work of cleaning the internet has been done by our relatives, some of our students, and this work involves removing pornographic materials. It removes really, really bad things from the internet so that we can enjoy the internet. And so we have to really think about what's the supply chain that's necessary to build AI so that we are comfortable. I always show this to my colleagues. to just watch this, because I do know quite a lot of my relatives use this as a way of income. And so we have to think and also bring our voice to society about how AI is used. I think top of mind now for medical students is how will AI, transform medical education. And so as I end, I want to remind you that this is one of the richest people in the world, right? In March said, within 10 years, AI will replace many doctors and teachers, and humans won't be needed for most tasks. As someone who builds and takes care of patients and builds AI, I find a gap in this reality. But I can tell you that when there's a power shift, we don't have enough GPUs, enough data sets, even in South Africa, in Kenya, and I can guarantee you that the AI that I build in Atlanta will not work here. And so I'm asking you, what AI do we want for South African healthcare? And as you think about it, I always like to acknowledge this is part of my team in Atlanta, and invite you for our datathon or next week, 15th and 16th, where we will be looking at trying to evaluate some of those chest X-ray producing AI systems to really see, can we come up with a better evaluation that's locally informed? Like none of those models will say, does this patient have tuberculosis? And so that we can really understand the progress that's made for AI. That's one of our big themes that we'll have. And then the second one is if you're a medical student or public health, anyone, a nurse, a technologist, come, we're going to try for you to provide a platform that you can interact with an ICU data set and ask questions without knowing how to program, and just see if you can really start to feel comfortable around AI. But the big debate and the big question we ask is, what do we think should be the AI that we build here? Should it be a bot or something else? So thank you, and I hope you learned something new. I think Vokos is out, so are you asking the questions? I don't know. Yes, introduce yourself and tell us who you are.
Thank you so much for your presentation. Amazing work, and I think there's a lot for us to think in the room. My name is Takura. I'm a PhD student under the supervision of Dr. Abidi.
Oh, okay. He mentioned.
Supervised by Professor Pukosi as well. I come from the angle of finance, so that's kind of my context. I don't have any medical background, apart from working within the insurance sector, where we work for medical schemes or medical insurers. But I just wanted to ask, on the theme of hallucinations, big challenge, right?
Yeah.
Have you seen any, within your vantage point, any good ways to detect that or mitigate against that harm? And have you, what do you recommend if, that's a concern for people? Because obviously in the medical space, if there's a hallucination, it can cause a big problem potentially in someone's life.
Yeah.
So how do what is your thinking around that?
Yeah.
Thanks.
Yeah. So just for the people who are online, if they didn't hear, is how do we deal with hallucinations, right? I think it's clear when ChatGPT came out, people thought that we're going to tame the hallucination problem, right? And it's not been possible, right? And so there are two things that, one is people with RAG, right? Retrieval augmented generation, which just means that instead of saying, learn from all of the world's text, learn from this database. So let's say the South African guidelines for cancer or the national cancer guidelines, so you ground it in what it learns, right? People have said that that's a better way of dealing with hallucinations. And because now you can have your experts already say, this is a guideline we rely on. This is WHO guidelines. We rely on WHO guidelines. If you recommend that, then that's fine, right? So that's how people have overcome that. But then the other people who are opposing could say, what if really there's something new outside the guidelines that you're not thinking about? Then you're really cutting out the opportunity or the promise of this generative AI, because it could bring you something that you didn't know, right? Because now if you constrain it, then you're like, you're not really getting the benefit. But hallucinations remain a big problem. Now, the good thing of grounding it in databases, and that's how people are doing it, I think ASCO has just done this for the cancer guidelines, is that you can update the database, right? When guidelines change, you can just update the database without worrying about updating the model itself, right? And so I think people have, we wrote sort of like a paper around this, but what we ended up putting out is saying that you need both. You need to ground in the things that are high risk, but for some of them, you do need to still be able to see what. Remember, if you ask the same question across five different models, you'll get a different answer, right? So you still, for the richness of the possibilities that are possible, people still think that you should still allow the model to be in the wild, but ongoing work. Yes.
So I think.
And
yes.
Okay.
Okay.
And you could be the dean, sorry.
No, I don't want that job. So I'm Prasenjit Mitra, and I'm a research professor at Carnegie Mellon University, Africa.
Awesome.
We're based in Kigali. I'm also visiting Bukosi.
Yes.
So my question is, at the end of the day, you showed us a lot of evaluations and so on. But at the end of the day, it's about comparisons between, let's say, AI only, AI plus human, and seeing, and then human only, and seeing which one works in practice the best. And AI plus human, as you said, could be worse if humans are relying overtly on AI and AI is getting it wrong. So at the end of the day, it's the bottom line, which saves the most patients, which identifies the most number of problematic cases and so on. So are there evaluations like that? And maybe that's the thing that we should use to say whether it should be used or not.
Yeah, so great. So first of all, we will be trying to do some evaluation of this on the Datathon, and I hope that you'll be joining us. The second thing is that, well, it's not straightforward. I think we always thought that, and I have some examples of those. We always thought that it's just human versus AI, and like all these three things, but it's not that simple. And the reason is, for example, we've seen that maybe here you would gain time, right? Just the workflow, understanding the workflow for radiologists here, you'd gain time. But the workflow for radiologists in my institution, you don't gain time. So efficiency, right, is not the value that you would be looking for. Now, given that people are not looking for efficiency, that means they're very organized in how they see their images, right? And so what we find is that if your AI requires just an extra click to see the result, no one clicks it. So it's almost like you almost need, it's the one place I think an agent would be good. You're almost like trying to see, okay, what did Judy say? She said this is a normal X-ray. I agree. And then you just don't interfere. And so people in Europe have tried to deploy AI as a second reader, right? So you're not really interacting with the human. But this, if you reorder the work list, because it doesn't really know, maybe the doctor called you to look at a study. So you're spending more time because you have new information from the doctor and you maybe need to look at another study. So because it's so focused on the single task, that's why, just optimizing for just using the AI, for diagnosis is extremely difficult. And then secondly, no human wants to be assisted on tasks that they're good at, and that's where we find the clinical subgroup. So for the more CS focus, I'll be giving another seminar that's more like technical, showing more evaluations. And you want to see where there's a gray zone, okay, is this a bleed or not, right? That's where I'm hesitating, the uncertainty, right? That's where you need, if you have a really good AI, then the next metric then for my deployment is when AI is wrong, is it usually wrong or is it usually right? Right. So then it gives you reliability. So that next step for the human-machine partnership has not been tackled. And that's why you'll see these articles in New York Times saying maybe we should not deploy humans in the loop because they're unpredictable, right? And these systems, it's so easy. Like you can build as many models as I want, but they're not useful either because they don't address a clinical use case that people struggle with, or that they fail from shortcuts that make it just easy for them to learn what takes me a second. I don't need you to, like that video for the, for the interaction is so slow, for the expert, because you can just look and be like, I know what this is, versus maybe a medical student who's trying to learn anatomy or something else. So context is what the AI deployments really struggle with.
I'm not jumping in. There was a question online.
Yeah.
I don't know if you can see that.
Oh, yes.
Joseph Mokara.
Thanks, Corneli. And Joseph is a doctor of law from University of Pretoria, and Prof. Okori's supervision asked about explainability. Is it possible to achieve explainability on all levels without compromising the model's performance? Yeah. So, well, the other profs in the room are shaking their heads and saying no, and that's true. I think I want to say that with this move to like the multimodal foundation models, people think that they're going to be more explainable. I don't think they are. I have a ton of examples, and that's why people, one of the tasks we'll do for a datathon is everything is evaluated on question and answer, right? The multiple choice question. I don't think that's enough, and that's not how like doctors tend to think. You're not thinking like, is this lab A, B, C, D, right? You're asking a specific question, and I'm hoping that we can, even if we come up with 10 questions that are just more robust, more clinically useful, I think that type of evaluation is going to be enough. But unfortunately, you cannot get enough explanation. The examples that I showed with the saliency maps, the hot areas, is very unreliable. In fact, if you change the order that you load your data, it's going to present different things. It's a little bit of it hallucinates. It tells us what the model is looking at, and it can maybe show you a big pattern, but it does not tell you really why the AI ended up with the specific decision making. But great area for research.
Yeah, I had a quick question around obviously the interests in the system, right?
Yes.
Bill Gates is saying doctors are not replaced. You're coming with a more nuanced approach.
Yeah.
You're saying it's not as complicated. And there might be unions, there might be pushback, because people might lose jobs.
Oh yeah.
So how do we decipher and see through all of that? And I imagine a regulator or the government might be a natural place to solve all of this. Have you seen any, because I think that's a big function as to the rate of adoption, the guidelines you're talking about, and so forth. Have you guys engaged directly or seen any engagement around, for example, the regulators? In South Africa, I think it's the Health Professions Council, HPCSA. In other areas, it's other regulators.
Yeah.
Have you seen fast, slow? What has been the reception from the regulators to try to maybe
Yes.
balance all these interests for these different stakeholders in the system?
So I'll speak about two contexts that I know, and probably because you can speak about South Africa more, is so Kenya is adopting the Europe way, the GDPR, very, very strict, right? So some of the things are saying, for example, all data must live in Kenya, right? So you need data science, data centers in the continent, very, very difficult to scale. Secondly, is saying that all patients, this I know is from South Africa more, all patients need consent before AI. You cannot do AI that way. It's just a fact. You cannot give proper consent, and you're going to be lying to the patients. And so, that model, I think, is going to even put things much, much slower, I think, for the continent. in the US, everyone is trying to figure it out. And if you've been watching the news, apart from hearing, the president ask about the Liberian president, how he learns to speak good English, one of the things about his big, beautiful bill is that he was saying no AI regulation, that, Silicon Valley is saying, so it's the same tension. They're saying, don't regulate us, you're going to slow us down. We're gonna do great if you just give us space for innovation. But the reality is that states are saying, we have to regulate this because someone has to be sued when some harm happens to a patient. And so, those responsibilities. So to you, I would say, it's not just sitting in the lab. You have to do outreach, right? The people who are making these decisions sometimes don't understand, right? You have to also think, and that's why I ended up with the impact of AI on our lives, even if you don't care about it in the medical context, on your education, the education of your nieces, your children, and and how our world is shaped. And we have to really have this dialogue about AI for social good, not just healthcare, education are just two pillars, and even around our relatives. Yeah.
Okay, so there's two pieces. Sorry. So one is that we're gonna have to stop the seminar online, but I think we're flexible in terms of time in the room. So I just want to say goodbye to people in the spaces. So hello everybody. We want to start again. Thank the health faculty. Thank Sisonke, thank Judy, so many people who made today possible. It's just that we need to kind of stop it somewhere. We will go on forever. But for the people in the room, you can still mingle and engage with Judy as well. So thank you. Sorry, I'm right here. I'm actually seeing myself now. You're seeing my chest in that space. So thank you, everybody. The recordings will be available probably later today for people who want to then come and revisit this. So I will
come for our datathon.
Yes, then there's a datathon.
And it's
wait. Yep. Are people still there?
Yeah.
I will put the link to the datathon for people who are around Pretoria next Tuesday and Wednesday. Just wait in the chat. Remember correctly and copy. And yeah, it'll be in the chat. There we go. Cool. I think everybody will still have access to the chat anyway afterwards.
Okay. Yeah. When we send, maybe when we send the recording.
Okay.